Hello everyone, welcome to my channel. Our today's topic of discussion is rational numbers and irrational numbers. Now, which numbers are called rational numbers? We all know the numbers which can be represented in the form P by Q, where P and Q both are integers, Q not equals to 0, and greatest common divisor of P and Q equals to 1. All those numbers are called rational numbers, right? So rational numbers are those numbers which can be represented in the form P by Q, where Q is not equals to 0, GCD of PQ means greatest common divisor of PQ equals to 1, and P and Q both are integers. We get innumerable number of rational numbers like 1 by 2, minus 3 by 4, 3 by 7, etc. There are innumerable number of numbers which are rational numbers, which satisfy the conditions of being a rational number. Now, there are so many numbers also which do not satisfy this condition. So, what kind of numbers they are? Yes, they are irrational numbers. So, irrational numbers do not satisfy the above condition. Okay, let's take some examples like root 2, root 3, root 5. This type of numbers are the irrational numbers, as they cannot be represented by the form P by Q. Now, if you want to show that whether this root 5 is an irrational or not, that is, if you want to prove that root 5 is actually an irrational number, then what you have to do? Let's first consider root 5 as a rational number. Let root 5 is a rational. So by this definition of rational number, what can we say? Root 5 equals to P by Q, where Q not equals to 0. Both of them are integers, and greatest common divisor of P and Q is equals to 1. Okay? So here we get P equals to root 5 into Q. Right? So this gives us P square equals to 5 into Q square. That means this P square is represented in the form 5 into Q square. So can't we say that Q square equals to P square by 5? So this representation implies, this means that P square is divisible by 5. Because as it is divisible by 5, so after dividing P square by 5, we are getting an integer, because Q is also an integer. Right? Therefore, we can say from here, P is divisible by 5. So as P is divisible by 5, can't we say let P equals to 5 into K, where K is an integer? Okay? Because P is divisible by 5, right? So after dividing by 5, we are going to get a quotient. We are taking it as K. Now, from this relation, from 1, we get Q square equals to 25K square by 5, which is 5K square, right? So Q square by 5 is also equals to k square. So from this we also get that q square is divisible by 5. Right? Because when q square is divided by 5, we are getting an integer. If k is an integer, then k square is also an integer. So q square is divisible by 5. So this implies q is also divisible by 5. So look students, here we get p is divisible by 5 and also we get q is divisible by 5. So p and q both divisible by 5. But according to the definition of rational number, GCD of PQ should be 1. In the standard form of rational number, greatest common divisor of P and Q, if we consider the form as P by Q, should be. So the greatest common divisor of P and Q should be 1, but here it is 5. So obviously it is a contradiction to our assumption that root 5 is a rational number. So this contradicts to our assumptions. Therefore, we may conclude root 5 is not a rational number. Okay? So here we find that root 5 is not a rational number. Just by the same procedure, we can show that root 2, root 3, root 7, this kind of numbers are not the rational numbers. They are irrational numbers. Now here, a very important thing to note, that is if you add a rational with an irrational number, or if you subtract between a rational and irrational, then obviously the result will be an irrational number. And that is why 3 plus root 5, 2 minus root 2, there are so many innumerable number of examples where you will see that the addition or subtraction of one rational and one irrational will give you an irrational numbers. Okay. Now we can prove this particular thing also. Let us first consider 3 plus root 5. Suppose we want to show that 3 plus root 5 is an irrational number. So just by the previous way, we can show it. Like if we first consider 3 plus root 5 is a rational, just like the previous proof, then we can write it as P by Q, where Q not equals to 0, both are integers, and greatest common divisor of PQ equals to 1. Okay, so clearly we get root 5 equals to P by Q minus 3. Now look students, P by Q as per our assumption is a rational. 3 is also a rational, because 3 by 1, it can be written in the form 3 by 1. And we know addition, subtraction, multiplication, division of two rationals will also give us a rational. So obviously P by Q minus 3 is a rational. But we have just proved that we have already proved that root 5 is an irrational number. Okay? We have just proved it. That is, root 5 is an irrational number. Then how this subtraction equal to root 5 can be written? It cannot be written actually. So, it contradicts, this presentation contradicts our assumption, right? This particular presentation contradicts our assumption that 3 plus root 5 is a rational. Therefore, 3 plus root 5 actually is an irrational number. Okay? So, hope today's discussion will be helpful for all of you. Thank you so much. Take care. Stay safe. Bye.